Hey, before we move on from the transaction class, there's a couple edge cases we have to consider before moving on to a new part of the project. The first edge case is one that we're familiar with. What happens if the amount in the update function exceeds the sender wallet's balance? Shouldn't an error be thrown, just like the create transaction method? Well, that is indeed a great idea. So let's cover this case by wrapping all of our existing code, except for the let declarations of the variables, within a new describe block that says, and the amount is valid. So we're going to take all of our existing code and place it within this describe block. So this before each, this it block, this one, and this fourth one as well. Let's cut this entire thing and then place it within the describe block that says, and the amount is valid. And now we can describe a situation where the amount is invalid. And in that case, we're going to expect that an error happens and the transaction doesn't go through. We have the case where the amount is invalid. And in here, we're going to say it throws an error. So that is our test in an if block. It throws an error. And this is structured very similarly to the create transaction method. We want an error to be thrown if the amount specified exceeds the balance. So in order to do this, well, we're going to make a transaction update. So let's call transaction.update with the sender wallet, a new recipient of foo, and then an amount that is valid. And our favorite number for this is 6 nines, 999,999. Cool. And if this happens, we're going to expect an error to be thrown. Now, in this case, we want to provide a callback function to the expect statement. And the result of this callback function is that it's going to call transaction.update. So let's place our code for the transaction.update with the invalid amount within the callback to the actual part of the expect statement. And then we can chain the toThrow method. And then in this case, we're going to have that familiar message that says amount exceeds balance. Sorry, you can't make your transaction. Cool. Now, while we have our minds wrapped around this test case, let's implement the code to get it to pass. In the command line, you should see that there is a new failing test. And yep, it didn't throw anything in the update function. So we need to implement that functionality in the local transaction.js file. In the update method, we're going to check if the amount specified exceeds the output amount sender wallet public key, or rather the output amount designated for the sender wallet public key. So if the amount is greater than this .output map and the amount for the sender wallet .public key, we're going to throw an instance of the error object. So let's throw a new error. And our message is that this amount exceeds the balance. Cool. Saving this, we should have a fully green test suite once more, and indeed, it's all good. Cool. Now, there's another edge case to consider. So far, we've tested the update with different recipients. But what's going to happen if we designate the same recipient over again? Heavens. Will our current code be able to actually handle this? Well, our current implementation is actually going to be a bit off because it would subtract the new amount from the sender wallet for the remaining balance. However, the amount designated for the same recipient would actually be overwritten to that most recent new value. So the solution is to add that amount for the recipient instead of overwriting it. But before we write that code, let's capture that with the test. So we're going to add a new describe block at the end of the valid case. And this describe block is going to say, and another update, but for the same recipient. So this recipient is extra lucky today. They're going to get even more currency. Cool. For this test, we're going to use the same recipient, but we need a new amount. So let's make a variable called added amount. And then let's assign this added amount value in a before each block. So before each. And for this value, let's designate something like 80, something valid that the sender wallet would still have left in their balance. And then like before, we'll call transaction.update. And in this case, we have the sender wallet doing the transaction. The recipient is still going to be the next recipient because that is the same recipient who just received the transaction as part of this update. And in this case, the amount is the added amount we just set right before. Cool. And for the test, we should check that this next recipient gets the added amount. So we'll have an if block, which suffice to say, it adds to the recipient amount. Cool. So let's check how much this recipient has now. We'll expect if we look at the actual value of the transaction output map, and then we find the next recipient, that this should be equal to the expected value of that first amount, which was the next amount that we have above. So notice that it's this next amount first, plus the added amount. So next amount plus added amount. Cool. Now that's a pretty long line, so I'll put this on its own. All right, nice. Likewise, we also need to make sure that the original sender has an appropriate remaining balance for the account when it gets updated. So it should subtract that new amount from the original sender output amount as well. So it subtracts the amount from the original sender output amount. And then we're going to expect that the amount designated to the sender wallet through their public key is their original amount minus the next amount, in addition to minusing the added amount as well. All right. So we'll expect that the transaction.output map, and if we access the sender wallet.public key, that this is equal to whatever their original sender output was, minus that next amount, and now minus that added amount as well. All right. As we save this, you'll go to the command line, and even though we added 2 more new tests, you're going to find that only one is failing because one is already passing. And that's because we wrote the code in the transaction.js file to already subtract the amount from the original sender with a new update. So that test is actually passing, but it's still good that we wrote that in place to make sure that subsequent updates to the next recipient also make sure that the original sender subtracts the most recent amount. Okay, so let's write the code in the update function to get this final test to pass. When we're updating now, we have 2 cases to consider. First, if this recipient already exists in the output map. If the recipient doesn't exist in the output map, which we can check if not this.output map recipient, well, we're going to do like normal. We're going to set an amount value for that recipient. So this condition should work because if this.output map for the recipient does not already exist, this will return undefined. And undefined acts like falsy in JavaScript, and not falsy will evaluate to true for the overall condition. Cool. Otherwise, we have a case where the recipient already exists in the output map, in which case we need to do something similar to our code below where we're updating an existing value. So we need to set this.output map for the recipient to this.output map for the recipient plus the new amount. So this should take care of adding that amount to the existing recipient. All right, as we save this actual implementation gets the test to pass. Cool. So with that, we've now implemented the code to make sure the update function doesn't exceed the balance from its amount, and it should update the amount for an existing recipient in the output map. Very cool. With that completed, we're now ready to evolve to the next level in this cryptocurrency system. Next, we're going to create the transaction pool. This more complex object is going to be able to collect transactions from multiple contributors. And this will allow us to connect multiple users in this cryptocurrency system. So let's move on and graduate to the really cool transaction pool structure.